Okay, guys, gonna go over the 5.1 or U5A1 material. So this is a little bit different now. This is solving problems using counting techniques. So we're getting into mathematics of probability and finite mathematics, and a little different than the stuff that we did up into including your big assignment. So this stuff's really neat. I enjoy this stuff, and what I'll do is I'll go over the note and make some of my own notes over here on Smart and back and forth. Okay, so here's the deal. We have some family, and they want to have some. They're gonna have a kid, and these are the first names that they've decided, and these are the middle names they decided to use. So there are three choices for the first name and two for the middle name. And what you do is you set up a tree diagram to figure out the total number of options. Okay, so let's look at that. So what's going to happen is, let's say the names are, I don't know what they were, but let's say the names are A, B, and C, which are horrible first names, but let's say we want to go with that. So we have three options for the first name, and then we have two options for the second name. So let's say they're Z and Y, and Z and Y, and Z and Y. Okay, so your kid's name could be BY, AZ, AY, BZ, CY, or CZ. Now, I kind of jumped around there, but usually when we do this, we don't. We just look at this and we say, look, AZ, AY, BZ, BY, CZ, CY. There's no repetition, and there's nothing missing. So these trees really help. And then you talk about, so what you can do at the end of the branch, these are called branches, is you could say the kid's name is AZ, this kid's name is AY, and go all the way through. And you figure out there are six different options. And we have three options for the first name, two for the second name or middle name. And you'll notice that 3 times 2 is 6. And in general, when we talk about counting principles, we talk about you're going to end up multiplying. So let's look at another question. Let's say that I wanted to get a sandwich from Subway, and there are 6 types of bread, and there are 10 types of meat, and there are 12 different toppings, and I can choose any or all of those. And then as you go through that, you have 6 branches here, and then each of the 6 branches has 10 branches, and each of these has 12. Now, this is a different question, so maybe reword this. This would be where you can only get one type of topping, okay, and one type of meat and one type of bread. So when you go to Subway, this question is actually not exactly the right thing, but let's say that's your scenario. You get one meat, one bread, and one topping. Okay, so this is your meat, 6 options, bread, and then topping. And you say, wow, that's a lot of sandwiches. Well, that is a lot of sandwiches. And if you drew this, you would end up with 6 times 10, 60 times 12. 60 times 12 is what, 720? 720 different options for your sub. And think about this. If there are actually 12 options and it's not 12 different toppings, sorry, and now I can actually come into the situation where I can choose a certain number of these toppings. I can choose all 12 or 3 of them or 2 of them or whatever. And then add in sauces too. Holy cow. You're going to be looking at a completely different question. And we'll get to that eventually. But you'll talk about, there's thousands and thousands and thousands of different options at Subway. Mind-blowing. Okay. So that's the basic counting principle here. What they did here is they added an extra name, I think, eventually. They added another middle name. Oh, sorry, they're gonna have 2 middle names. So now they have 2 different names here, Chase or Alex. So the kid's gonna have three names, and now you have first name, first middle name, second middle name. So again, because there's another option, you're gonna multiply that here, and then you end up with 12. Okay. In general, this is the product rule. So during DEAR, drop everything and read. Students go to the front of the class to pick up something to read. There are 20 magazines and 35 books. You are going to select a book and a magazine. How many different options are there? Again, you would draw a tree, 20 by 35, but you're not going to draw that tree. But there are 20 options, and then after that, there are 35 options, and what you do is you multiply 20 times 35, and you get 700. Okay, so it's kind of neat. Tons of this stuff. If you're into different games, board games, but especially and video games too. But if you look into really simple, if you look at like some of the game shows on TV, tons of simple probability that's in there, like choose this or choose that. Should you pick the 5 or roll the dice or whatever it is. Price is Right. What's the other one? Let's Make a Deal. All those things have tons of options, and then you also have greed gets thrown into there, and people's envy and people's want for more is also kind of interesting. But anyway, If you're going to get a book or a magazine, well, this one's a little easier. You got to be careful on the wording here. Well, now there are 35 plus 20, 55 different things to read. So you just have 55 different options, okay, because you're only choosing one. So um, there's that. Okay, if first action can be performed in M ways and the second action N ways, then they're M plus N. So let's talk about this. Let's look at this. You have just received an invitation to your cousin's wedding. He knows that people like a choice, so he has several different options to eat. You can choose beef, chicken, pasta, and there are 4 pies and 2 cakes. How many different meals can be ordered? So here you have 3 options for the main course, 6 options for dessert, but I forgot that you can either have super salad. So 2, 3, 6, just multiply it straight out. So there are 36 different choices. Notice that even though the dessert option used the keyword and you had only one choice, not pie and both, so you need again you only have one choice between the pie and the cake. Oh my, hold on. Let's go down here. My mouse is frozen. There are 4 pies and 2 cakes. So just note that you don't get a choice of pie and cake. You just get one choice there. So a lot of the wording can be like, some of you might have gone 2 times 3. No, 2 times 3 times 6. Sorry, 2 times 3 times 4 times 2, which kind of makes sense. But that would be saying that you get 2 options for the starter, 3 for the main, and then you get a pie and a cake, which is not true. That's gluttony. Okay, let me just pause this for a second. I gotta go get a new mouse. Okay, got a new mouse, and that's it for the note. I'm gonna move on now to the assignment and just kind of jump through that. You have a little quiz with this also. Give me a second here. Cutting principle worksheet. So, and solutions here, and then there's a quiz. So let's just go through the worksheet real quick. Construct a tree diagram and determine the number of different sundaes that can be ordered. If there's 2 ice creams and 3 sauces, so you're just going to multiply those out. And then sprinkles. So here's a good question. So if I was to do this one here, and there were, I believe, 2 options. Hold on a second. I'm trying to clean this up. How do I do this? It's getting blocked here. Okay, so if I have 2 options for one thing and then 3 options for the other thing, so here let's say it was chocolate and vanilla, and then the toppings were, I don't know, let me do the actual question. Let me go back here. So chocolate and vanilla and chocolate, caramel, and strawberry sauces. Okay, so here chocolate, caramel, and strawberry. I guess if I had more time, I could chocolate, caramel. So, and this is chocolate and vanilla. Ice cream, and then there are 2 times 3, which is 6 options. Now the next question is sprinkles, and then yeah, you can ask yourself, hold on, I don't really, if I only have one option for sprinkles, does it look like this? Well, no. And where this comes into play, because this branch would say chocolate chocolate ice cream with chocolate sauce with sprinkles. But if I want chocolate ice cream with chocolate sauce and no sprinkles, can I do that? Not according to this. So what happens in this situation is what you can add is another branch that says sprinkles or no sprinkles. Okay, so this guy here is chocolate ice cream, chocolate sauce, no sprinkles. This one here, sprinkles. So if you have an option of yes and no, it'll just be a branch like this, like a yes and a no, depending on what the option is. Now, maybe we could have done the same thing here. Maybe we could have said, look, I don't want any sauce. Okay, so no here, and then break off more branches here. So instead of 2 times 3, it's 2 times 4. Okay, I think you would have to have an option here. You couldn't have no here because that's no ice cream, and you're just eating sauce, which is silly. But I guess you could do that, chocolate with, but I guess in this question they didn't really give you that option because it's a sundae. So, but just know that if you have a yes no option, it is another branch like this. Okay, and if it's let's do chocolate sauce, caramel sauce, strawberry sauce, or no sauce. Okay, there's 4 options here. Just a 4th option. Besides that, I think the rest of the questions are really straightforward. Okay, and that'll get you ready for the quiz. Um, have fun. Okay, send me an email if you have any questions. Take care.